This is question number 10 of homework 5 for chapter 5. So this setup reads relatively long compared with other questions, but actually up to, this sentence here, it will drop to 2 workers for every retiree in 2035. All the sentences before this one are just a context. And probably except for the age, because later on we're going to use that to calculate the number of payments or number of deposits. So let me just start start my reading from this sentence after one I just read. Mere House retirement plan pays 13% interest annually and allows him to make equal yearly contributions. So immediately this will be a annuity problem, right? Upon retirement, Mearhouse plans to buy a new boat, which he estimates will cost him $200,000 in 36 years. Why 36 years? That's because he's currently 24 and he plans to retire at age 60. So that will leave 36 years to go. He also, so I think probably helps to draw a chart just to help us organize the information, right? This is like, I'm just writing this current time point to be 0. So this will be 36, right? The retirement. So this is retirement. And so here he wants to have a certain cash outflow, right? $200,000 to buy a boat. So that's the price and cash outflow, $200,000. And the interest rate before the retirement date is 13%, right? The interest rate there. So let's continue to write this. This is R1 is 13%. So now let's continue to read the setup. He also estimates that in order to live comfortably, he will require a yearly income of $80,000 for each year after he retires, based on family history. So what happens is, based on family history, Millhouse expects to live until age 80. So that is, he would like to receive 20 payments of $80,000 at the end of each year. Why 20? Because he plans to retire at age 60. So he estimates that he can live until 80. So that leaves 20 years to go. So that's 20 payments. So now I can sort of finish this chart by extending this. And so this will be adding 20. So that gives me this to be 56. Remember, this 56 is not the age. Here is relative to the current point that Mearhouse stands. So the current point here, actually, this refers to 24 years old. So this 36 is 60 years old. And here is 80 years old. So after that, he wants to have some annual payment, and that will continue for 20 years. So this annual payment is provided by the setup, right? That's $80,000. So this is $80,000 until his death, and this is the end of the year. So that immediately reminds us that we should use the ordinary annuity. Yeah, we should treat this as an ordinary annuity. So now this question will become very clear. When he retires, Mearhouse will purchase his boat in one lump sum and place the remaining balance of his savings into an account which pays 6% interest, from which he will withdraw is $80,000 per year. If House first contribution is made 1 year from today, again, that's also should be treated as an ordinary annuity. And his last is made on the day he retires. How much money must he contribute each year to his retirement fund? So basically, before this retirement date, he also makes annual contributions. So this question is asking us, what is this annual contributions, basically? And also remember, the interest rate after the retirement date will be different. So we write this as R2. And going back to the setup, R2 is assumed to be 6%, right, after the retirement date. So we need to be very mindful about this difference between these two interest rates for before the retirement and after the retirement. So now the question is basically to figure out this payment, right, annuity payment. So in order to figure out this payment, it probably is, if we know the, for example here, the future value, right, the future value of this annuity, then we can figure out the payment, because we also know the interest rate, right? So we know the future value of this annuity. One of the future cash flows is this price of the boat, right, $200,000. But that's not the only cash flows House will need, right? Because they also need a $80,000 per year annuity until he estimates that he dies at the age of 80. So that means he also has $80,000 per year annuity for this future value. For this future value in terms of the current time point he stands, but for at this particular date, right, when he retires, he will need both this $200,000 of lump sum cash in order to pay the to buy the boat, but also need to fulfill this sort of relative to the $80,000 after retirement. Now this will become the present value, right? We will also need to fulfill the present value requirement of these $80,000 20 payments annuities. So that's basically how we analyze this question. So once with that information in mind, we can now go to the calculation stage. So first, why don't we figure out what is the present value of this $80,000, right? 6% ordinary annuity, right? So that's basically these payments here. So obviously that's easy to calculate, right? Because we know everything which is needed in order to calculate this present value. So equals PV and open rate will be 6%, and MPER we have 20, right? 20 payments, and payment basically I add a negative sign in front of it because I want a positive present value. And all other information we could just leave them to be their default values. Future value is 0, right? Because there's no future lump sum payment and other than the annuity after retirement. And type, it means or beginning of the year or end of the year convention. Here it's the default state, which is the end of the year convention, because we have ordinary annuity. So that's the present value. But now we should remember this present value is in terms of this particular date, right? This is the present value we just calculated because remember I said this is 20 payments, right? 20 payments, 6%, $80,000. So this is the present value of all those 20 payments of $80,000 per year. So now the future value of this annuity, which is the annuity before the retirement, that's the annuity that Mearhouse needs to um, accumulate each year in order to meet his retirement demand. Basically, his retirement demand is the sum of these two cash flows. One is the price he needs to pay the boat for the boat, and two is the present value of this annuity after the retirement. So we have basically just figured out the present value of this annuity. We just need to sum these two up, and then that will become the sort of the future value, right? Future value of annuity, and um, this interest rate here is 13% rather than 6%, and this is also um, ordinary annuity. So again, based on our analysis, this future value of this annuity is basically the sum of this and this $200,000 price to the for the boat. It's this amount, and now we know the future value, we know the interest rate, and we know the number of compounding periods, right? We have 36 annuity payments. So now I can use this information to figure out what should be the payment, right? That should equal to PMT, the payment function in Excel, and open that. The rate is the 13%, and NPER is the number of annuity payments. So that's basically, I guess that's 36, right? 36. And present value, there's no present value here. And future value will be what we just calculated here. If I want a positive payment, annuity payment, I just need to add a negative sign in front of this future value, and then I can close this now because I don't have to worry about the type. It's by default that's ordinary annuity, and that's the case here. All right, so the payment you can see looks like there's something. Yes. Looks like it's a bit small, right? Because and I guess the reason is because it's the time period is relatively large, and also the interest rate is really high. So that's the reason why this becomes a very small amount. So each year he only needs to accumulate, only needs to deposit this much of the money. And just double check whether this is yes, equal yearly contributions because it's not monthly contributions. Okay, so I guess we have just done all the calculations, but this question actually has different parts. So now let me try to answer each part. In order for him to withdraw 20 payments of $80,000 at the end of each year after he retires, how much money will Mearhouse need to have in the retirement date account, earning 6% when he retires? So that's basically what we calculated for the first number, the present value of this annuity. Right? Just copy that number back, and remember to get rid of the dollar sign. And also, I think I follow this rounding requirement as well, round to the nearest cent. Check my answer, and then just continue. Upon retirement, Mearhouse also plans to buy a new boat, which he estimates will cost him $200,000 in 36 years. How much money would Mearhouse have in the retirement fund to achieve the goal when he retires? So that's basically the second number we just calculated, right? That's the sum of the present value of the annuity after retirement and that lump sum $200,000 payment. So check my answer. And finally, I guess this is also the It's asking what is how much money must he contribute each year for his retirement fund to achieve the goal. So this is what we just calculated here. Just copy that number back and get rid of the dollar sign. And also, I think follow this rounding requirement, round to the nearest cent. Okay, so we are done with this question. Oh,